Imagine staring at a single, distant light bulb for 4 years straight, waiting for a fruit fly to pass in front of it. That's essentially what NASA's Kepler Space Telescope did, but for hundreds of thousands of stars simultaneously. The goal was to detect exoplanets using the transit method, a tiny, almost imperceptible dip in a star's brightness as a planet crosses its face. In theory, it's a simple, elegant idea. A repeating dip means a repeating orbit. But the light from a star isn't a perfect, steady beam. It's a chaotic, flickering whisper in the cosmic dark. A star is a roiling ball of nuclear explosions. It has star spots, massive solar flares, and pulsation waves that all change its brightness moment to moment. On top of that, the telescope itself isn't perfectly still. It jitters minutely. Cosmic rays, stray particles from deep space, strike the sensor and create false spikes of light. The actual signal of an Earth-sized planet is a brightness dip of less than 1/100th of 1%. Finding that signal is like trying to hear a single person whisper your name from across a crowded, roaring stadium. For years, astronomers fought this noise with algorithms designed to look for perfect, periodic, U-shaped dips. These automated systems were a digital sieve, shaking through mountains of data to find the golden nuggets. But this sieve was profoundly biased. It was programmed with our assumptions of what a planet's transit should look like. If a signal was slightly misshapen by a star spot, or if the orbit was highly eccentric, the algorithm would often pass right over it. We were essentially looking for our lost keys, but only under the streetlights we had built ourselves. This is where a different kind of intelligence comes in. Not an intelligence programmed with rules, but one that learns from experience. A convolutional neural network, a type of AI, can be shown tens of thousands of confirmed planet transits. It also sees countless examples of noise and false positives. It doesn't learn the rule, look for a U-shape. Instead, it learns the subtle, underlying statistical texture of what it means to be a planet. It learns to see the whisper in the stadium, even when the roar is deafening, and even if the whisper has an accent it's never heard before. In 2017, researchers pointed such an AI at the old, already analyzed Kepler data for a star called Kepler 90. Humans and traditional algorithms had found 7 planets there. The AI sifted through the same exact data, the same flickers and noise, and found something everyone had missed: a weak signal of an 8th planet, Kepler 90I. The planet was always there, hiding in plain sight within the numbers. It wasn't that the AI was smarter, it was that it was unbiased. It didn't have preconceived notions of what to ignore. This isn't just about finding more planets, it's about changing how we analyze cosmic data entirely. An AI can stare at the raw pixels of a galaxy image and classify its shape faster than any human. It can listen to the radio signals from a pulsar and detect gravitational waves warping its timing. It can analyze the spectrum of a star's light and determine its chemical composition with superhuman precision. The AI is a universal pattern recognition machine, and the universe is nothing but patterns. So, what is the role of the human scientist in an age of AI discovery? Perhaps it shifts from being the one who peers through the eyepiece to the one who curates the data. The astronomer becomes a trainer, a teacher for a silicon mind, carefully selecting what it learns from. They become the interpreter, the one who takes the AI's statistical output and asks the crucial question: what does this physically mean for the universe? The AI can find the correlation, but for now, it takes a human to seek the cause and feel the awe. When an entity that cannot think or wonder makes a discovery, what does that change about the act of discovery itself? Kepler-Linde I existed long before we did. The data of its transit sat on a hard drive for years. A human programmed an AI, which then pointed to a pattern. Where in that chain of events did the discovery actually happen? The AI isn't a scientist, it's a tool. But it is a tool that reflects our own intelligence back at us, showing us the limits of our own perception and forcing us to question if discovery is a single moment of insight or simply the last step in a long computational process. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.